Hey guys, Mr. O'Sullivan here. Hey, we're going to take a look at 2016, number 5 on the free response. It's a no-calc problem. It has a few things going on. It's going to ask us to find the average value of a function. We're going to find the volume uh, of a solid, and then part C is going to be a related rates type problem. So let's go ahead and dive in here and see what we got. So they give us a diagram of our funnel. It says the inside of a funnel of height 10 inches has circular cross sections as shown in the figure above. At height h, the radius of the funnel is given by r is equal to 1/20th times the quantity 3 plus h squared, where 0 is less than or equal to h, less than or equal to 10. Units of r and h are in inches, and then we're asked to do three things. First off, we're asked to find the average value of the radius of the funnel. Part B, we're asked to find the volume of the funnel. And then part C says the funnel contains liquid that is draining from the bottom. At the instance when the height of the liquid is h equals 3 inches, the radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. At this instant, what is the rate of change of the height of the liquid with respect to time? All right. Okay, so let's go ahead and dive in. So for part A, we're asked to find the average value of the radius of the funnel. So they're asking us basically for the average value of a function. And in this case, our function gives us the radius of the funnel in terms of h, the height. All right. The given the height. Okay. So really, what we're asked to find is the average value of a function is equal to 1 over b minus a times the definite integral from a to b of f of x dx. And that gives us the average value of f of x on the closed interval from a to b. Okay, so that's kind of like the formula that we're going to go with. And so for our purposes, this is going to be our interval is from closed interval from 0 to 10. So a is 0, b is going to be 10, and our function is going to be r, or r at h. So in the context of our problem, this is going to look like 1 over 10 minus 0 times the definite integral from 0 to 10 of r, which is defined as 1/20th times 3 plus h squared dh. And then we basically just have to evaluate this. Okay, well, this isn't going to be too terribly tough. So we might simplify life a little bit. Let's go ahead and pull this out. And so really, we've got, I'm just going to rewrite this below. We've got 1/10 times 1/20th when I pull that through. So that's going to be 1/200th, definite integral from 0 to 10. Now we just have 3 plus h squared dh. And now FTC part 1. Got to integrate this. Let's not forget our constant. So I'm just going to keep carrying that along. Antiderivative is going to be 3h plus h to the third over 3. Our bounds along. Then plug in our upper bound again. Still have our constant out here. Plug our upper bound in. 3 times 10 plus 10 cubed over 3 minus, plug our lower bound in. Since I've got an h there and an h there, that's just going to be 0. And that's my answer. So that is the average value of the radius of the funnel. over our integral, over our interval height of 0 up to a height of 10. Okay, not too bad. Confidence builder. And now want to find the volume of the funnel. All right, well, they told us that the inside of our funnel of height 10 inches has circular cross sections. Okay, well, that's really all we need to know, because what we're asked to set up is going to be a definite integral, and our integrand, this integral that's going to give us the volume, our integrand needs to represent the area of a cross section. And in this case, our cross sections are circles, so we're going to need the area in terms of r. So let's start to set that up. So this is B, and we're looking for the volume of the cylinder. Sorry, volume of the funnel, not a cylinder. That would be a much easier problem. So the volume of our funnel. Okay, so it's going to be the definite integral, and we're going to have h equals 0, h equals 10, and then our cross section, our integrand here, is the area of our cross section, which is going to be circles. Now those are going to have to be, I'm sorry, I think I misspoke earlier. The area of our circle is going to have to be, we know that's going to be pi r squared. But again, in this case, we're given a function for r, so that r is going to be in terms of h. So really, this is going to be pi times r, and r is given as 1/20th times 3 plus h squared. And we have to recognize all this, including that constant, is squared. So all of this represents r. So again, this is just pi r squared. And that's going to be respect dh. Okay, so now if we go to evaluate this, just FTC part 1, maybe one thing we can do is take care of the constants here. So we got pi, we can pull that out. So we have pi, pull that outside our integral. Then we're also going to have the 1/20th is going to be squared. So that's going to be 1/400th. Just going to park that underneath the pi. So then our remaining, what we have left inside our integral from 0 to 10 is just the 3 plus h squared squared. Okay. dh. And what I would probably do, again, just to make life even a little bit easier, I can wrangle this a couple different ways. I'd probably do a rewrite. And I just have, again, my constant, pi over 400, integral 0 to 10. I'm just going to expand that. So that's going to be 9 plus 6h squared plus h to the 4th dh. Make sure I did that right. 3 plus h squared. Factor that. 3 times 3 gives me 9. Outside 3h squared. 3h squared gives me 6h squared. And then h squared times h squared gives me h to the 4th dh. All right. So now I'm just going to rewrite that. because I love to rewrite stuff. So I have pi over 400, definite integral from 0 to 10, 9 plus 6 h squared plus h to the 4th dh, and I'm off to the races. FTC R1. Don't forget the constant, pi over 400, and then the antiderivative, 9h plus 6h to the 3rd over 3. I'll reduce that in a second. H to the 5th over 5. I'm not even going to reduce that because what's the point? 0, 10. Now I'm going to substitute in my upper bound. So I'm going to get pi over 400 times the quantity 9 times 10 plus 6 times 10 cubed over 3 plus 10 to the 5th over 5 minus, plug in my lower bound. I look at my integrand and I see h in each one of my terms. So that's just going to be 0 out. I'm done. That represents what? That represents the volume of the funnel. I could kind of show that I know my stuff. And if that's the volume, then that's going to be, and if this is represented, if my dimensions are in inches, height of 10 inches, and the radius is also given in, radius and the height are in inches. So I know this is going to be cubic inches. Okay, all right. So there's A and B, and that leaves us with part C, which is the related rates portion of this problem. So I'm just going to copy this down below here. So my okay, so part C says the funnel contains liquid that is draining from the bottom. At the instant when the height of the liquid is h equals 3 inches, the radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. At this instant, what is the rate of change of the height of the liquid with respect to time? Okay. Well, I remember about related rates. First step was read the problem. Just did. Now what I want to do is I want to kind of also copy this diagram just to kind of have a good idea of what's going on here. So there's my funnel. Okay, after reading the problem, what I want to do is kind of convert words into sort of calculus speak, calculus notation. So one thing, if I see this, it says funnel contains liquid that is draining from the bottom. Okay, so the liquid is coming out at the bottom. At the instant when the height of the liquid is h equals 3. So we're going to say this distance here, h equals 3. At that particular instant, says the radius of the surface of the liquid, so this r right here, is decreasing at a rate of 1/5 inch per second. Well, that's telling me, what they're telling us right here, that the radius is decreasing at a rate. Well, they're telling us dr dt, because that is the rate that the radius is changing over time. And since it's decreasing, that's equal to negative, and what's the rate? 1/5 inch per second. So dr dt is equal to negative 1/5. And then if I keep reading, at this instant, what is the rate of change of the height of the liquid with respect to time. Okay, so what I'm asked to find in this problem is the rate of change of the height of the liquid, which I'm gonna, that the calculus notation for that, rate of change of the height, be dH dt, the height with respect to time. So that is what I'm asked to find. So I'm really asked to find dH dt such that h dH dt such that h is equal to 3 and dr dt is equal to negative 1/5. So now I just have to come up with an equation for dH dt that has an h and has a dr dt in it. Okay, where could I start to come up with that? Oh, hey, look, I've got an equation that relates r and h right here. So that's going to be my starting point. That's kind of the next step there in solving related rates problems, is looking at, okay, what's a geometric formula that I'm going to use? Here's my geometric formula that relates radius and height. And I'm going to now take that geometric formula and take the derivative with respect to time. So I have r is equal to 1/20 times the quantity 3 plus h squared. Okay, I could probably dive right in. I'm going to just do a quick rewrite, distribute the 1/20. So I'm going to get 3/20 plus 1/20 h squared. So that's what r is equal to. I probably could have wrangled that, left it alone, but rewrite might be a little bit easier. Okay, so here's my geometric formula. Now I'm going to take derivative with respect to time, both sides, and I'm going to get dr dt on the left side is equal to ddt of 320, that's a constant, that's 0. Now it's just going to be power rule. So this is going to be 2 times 1/20 is going to be 2/20 h. Subtract 1 from that, that's just power rule, but I'm not done, times, you know it, dH dt. And I'm glad, because I need those three things to show up. I need dH dt, because that's what I'm looking for. I need h equals 3, because that's one of the variables in my equation. And I also need dr dt, because that's the third variable. So now I'm covered, asked to find dH dt, and I'm given dr dt and h. So what I'm going to do is substitute in dr dt, which is negative 1/5, equals 2/20. H is equal to 3. And then dH dt is what I'm looking for. So I'm going to just solve for dH dt. I'm going to multiply by 1/3. That takes care of my 3. And I'm going to multiply by 20 halves, also known as 10. Cancels that, and so I get dH dt is equal to negative 1/5 times 1/3 times 20 halves. I'm not going to simplify that. That's my answer. I'm just going to double check. This instant, the rate of change of the height with respect to time. Well, I know my units for height are in inches. So this is going to be inches And my units of time, I believe, were seconds. So that's inches per second. So that is the rate of change of the height of the liquid with respect to time when h is 3 inches. All right. Hope that helps. Thanks, guys.